The synthesis involves putting all the information you found at all the sites together into one whole explanation of the area. One key thing that needs to be done in synthesis is put all the information onto one diagram. So if we have the top of the sill here, we have the cooling joints like this, so we've seen cooling joints. Up here we had, this is here would be site 4, this actual contact was 4A, the marble was site 3. Now at the bottom of the sill we saw a number of features, and we'd want to show here that the sill had been following this bedding plane and then gone up to another one. In actual fact, we need to rub out this section here. Oops. And draw this properly. An offshoot of magma there as well, that would join that one there. Now we have the vertical cooling joints, and you'd put all this down here would be site 5, this area here. So you put, just drawing a schematic version of what you've seen. So you need to label all the key features like the cooling joints, the thickness of the sill. How thick was it? Was it about 70 meters or something thick? We have a chilled margin of basalt. We had the baked margin here of marble, and a baked margin of marble here, because above this area was the limestone, and that would be site 1. So we're trying to show this is we have a contact. We saw the actual contact at site 4 here. We've described the marble here, site 3 and site 5. This was also a zone of, this is the finer grained chilled margins of basalt. The rest in the middle is a dolerite. We have dolerite here, we have basalt at the edges, the chilled margin. We have the marble, which is the baked margin. Now with all this information in one, you can see straight away that it is definitely a sill. It can't be anything else. The reasons being, we have a contact and a baked margin above, which can't happen in a sill. In a lava flow. It has to be in a sill. We do have a baked margin below, but that could happen in both. This little injection of magma here is another feature of a sill. A lava flow could not inject magma underneath through a bedding plane. That's what a sill does. And a sill here is only a sill that could actually transgress from one bedding plane to the next. So if you put all your features onto a diagram like that and explain them around, maybe on an A3 sheet or an A4 sheet with all the explanation, that synthesises it, puts all the information into one diagram to explain what's happening. Another part of the synthesis would to build a geological map, or draw a geological map. This is a bit more tricky, but it will look really good in your coursework. So you have all your sites marked on. So you have one site here, let's put it in red. So we have site 1 here, we have site 1A there, site 2 here, site 3, site 4, site 4A, and down here somewhere, site 5. Those are all the different sites. Now, we know the altitude of each of the sites, we know the rock types. So, for example, we want to draw in the top of the sill. Now the sill was seen at this locality here and this locality here, and the contact between the two was here. It seems that the sill was at the top of the sill was just under 500 meters. Now 500 meters is this contour line. So this contour line is pretty much the top of the sill. Anything below that is sill material, anything above it is limestone, and on the boundary would be the marble. Because both rocks, the limestone and the sill, are horizontal, we can, nearly anyway, we can assume or extrapolate the sill top being wherever the 500 metre contour line is. So if we get a colour, and it's a bit wide, that one, make it a bit smaller. We can draw in so let's draw that in. Along this line here is essentially the top of the sill, so just under the 500 metre line is where the sill will crop out. Now we don't know it comes around here, we're just assuming, this could be in your evaluation for further investigation. That's the top of the sill. Now the top of the sill will also be on the other side at 500 metres, and 500 metres on the other side is somewhere, let's see if we can find it, it is this one here, somewhere at the top here. You can use your map more carefully. There's a 500 metre line here, that's the top of the sill on the other side. Now above the sill, all of this area is the limestone, so you could put some sort of marker here, because site 1 was limestone, site 2 was the dolerite, so that's on the dolerite, that's fine. Now the rest of this would also be limestone over here, and you'll see there won't be many streams or rivers running in these areas, which is indicative of limestone. In between the two, obviously there will be a area, just it's hard to draw in, but you can draw a different colour, just that boundary would be where the marble is, and that's what we saw at site 3 and site 4A, and you can draw that in as an area of contact metamorphism at the top of the sill, and the same would be possibly, although you'd have to investigate it, over on this side as well. Now what about the base of the sill? Well, the base of the sill was found at site 5 down here, and we said it was about 420 metres, which is harder to see, but you can just about locate that at about somewhere, let's have a look, about this area here. You'd use it more accurately than me, that should be at the base of those cliffs, and up there, something like that. So all this area is all this area, and that's under the reservoir, as you'd expect, because the reservoir wants an impermeable layer. All of this is the sill, and if we followed it round, it would go on and round like this. You can see the rivers are now just here. There's rivers flowing over these areas because that's the impermeable sill. So you're drawing a map to show the dolerite. If we had gone further round there, we should have seen that. And you can even map it onto the other side of the other side of the river, and it would look something, if you followed it, there's the 4, this is the sill again, in this area here, the river, oops, wrong bit, let's go back over those. Section, so the sill is in this is all the sill material through here, and you see these are all the cliffs appearing. And underneath, in the area underneath, is the limestone again. So this area would be limestone, you could draw that in as well. And you have a geological map showing you where we walked. We walked from site 1 on limestone, we descended to this little river that cut into the sill. We walked up here, along here to eventually see the marble. Site 4 was the river again, where the sill is exposed. Then we walked up the river, and we found the contact here between site 4A, between the marble and the dolerite, and then we scrambled down through the sill down by the side of Cauldron Snout to the River Tees, and walked along to Site 5, and we were now at the base of the sill. And so you have a geological map. Lastly, for the synthesis, you can build or draw a cross section and explain the geological history of the area. Now, if you locate your key, what we can do is draw in here. The sill is this area here, because this point here was Site 4, this was Site 3, this join here is Site 4A, and Site 5 is down here. So those are our sites. This is the dolerite sill, and we walked from here down to Site 3, 4, 4A, down through the sill to Site 5, and that's the River Tees on the other side. The sill would extend across the other side of the Tees, the river's just cut through it. We would have the limestone concordant with the sill. There's all the limestone that we walked off Site 1 here, and there's a layer of limestone underneath, because the sill is intruded into the limestone, the Carboniferous limestone, so it must be younger than Carboniferous limestone. And we have an area of metamorphism between the two. That's what we saw at Site 3 and Site 4A, so you show that there, and underneath as well there'll be an area of metamorphism. Again, all this synthesis keeps showing it's a sill rather than a lava flow. All the features explain that. Site 1 is up here, Site 1 there. Now the adit mine was a vertical, so Site 2 is here. The adit mine was a vertical shaft. Now what we think is that actually it's not affected, the sill came across later, and that this taps into a source. We think there's a magma source deep underground, a batholith or pluton, which fed the hydrothermal waters, went up the fault line to form the adit mine. There's probably nothing to do with the sill. Here you can put question marks because you don't exactly know what's underneath and whether this happened, but that would be my interpretation of a cross section. Then you could use this to explain the geological history, or describe the geological history. The first thing that happened was the limestone, warm, shallow, tropical sea. In the Carboniferous, you can use your Carboniferous understanding to explain this. Then there was an injection of magma along, it's like dike ascent. It's near the surface, it pushes the bedding planes apart to inject this sill material. As the sill comes through, it metamorphosed the country rocks above and below. Millions of years later, there was a batholith, hydrothermal fluids injected through a fault line to form this mineral vein, and over time the surface of the earth has been eroded to expose the sill and cause a little bit of weathering and oxidation on its surface. And there we have geological history and the synthesis. At the end of the synthesis will be a conclusion, and the conclusion would just go back over the key hypothesis and the key findings to say whether you were proved correct or not.